All right, we are doing notes 4-1 today, solving single variable equations and inequalities. So first up, our learning target. I can solve equations and inequalities with one variable. All right, so we've got a couple of review problems here. These are equations because they all have an equal sign in them. And remember, the way that you solve equations is to get the variable, so in this case, n, all by itself. So when I look at the 6, I say, okay, the 6 is being multiplied. The way that you get rid of it is to divide. So I want to divide by 6 so that those cancel. Whatever you do to one side, got to do to the other. Divide by 6. So on this side, I'm left with n equals 36 divided by 6 gives me 6. That's my answer. Okay, the next one. This is a two-step problem. We're still trying to solve for n, but now I have two things in the way. I have this 2 that's being multiplied, and I have this 10 that's being added. So you want to start furthest out or do order of operations in reverse. So we're going to get rid of the plus 10 first. So the way that you get rid of plus 10 is to minus 10. Whatever you do to one side, got to do to the other. So those cancel. And we have 2n equals 34 minus 10 is 24. This 2 is being multiplied to that n. That n is still what I'm trying to get by itself. So I'm going to divide by 2. Whatever you do to one side, got to do to the other. And I get n equals 24 divided by 2, 12. All right, number 3. We actually have two options for number 3. So you see these parentheses here. We can actually distribute and then solve it, or technically that 9 is being multiplied times everything. So if we wanted to get rid of it, we could divide. So let me show you both ways of how to do it. First, I'll go through and I'll distribute. So when I distribute 9 times 8, you get 72 plus 9 times x, 9x equals 27. Okay, I'm trying to solve for this x right here, so I need to get rid of that 72. That 72 is positive, so the way that I get rid of it, minus 72 minus 72. Okay, so 27 minus 72 gives me negative 45. So those cancel. 9x equals negative 45. Divide by 9 on both sides. And we get x equals negative divided by positive is negative. And 45 divided by 9 is 5. Now, like I said, you could have done this another way too. If you had started up here and said, well, that 9 is being multiplied, I want to divide by 9. Let me show you the other way to do it. If I want to divide by 9 and divide by 9, those 9s cancel. I'm left with 8 plus x equals 3. Still trying to solve for that variable, that x. That 8 is positive, so you get rid of it by subtracting 8. X equals 3 minus 8, negative 5. You'll get the same answer either way, but that's one option if you want to, instead of distributing, you'll have one less step of work and your numbers will be way smaller. So that's review of solving equations. This is something that you've done in previous math classes. So what we want to focus on today more is the inequalities. So an inequality is like an equation, except instead of an equal sign, you have one of the four inequalities. Greater than, less than, greater than or equal to, less than or equal to. And instead of one solution, so for instance, 6 is the only thing that will work in that equation. 12 is the only thing that will work in that equation. -5 is the only thing that will work in that equation. That's one solution. You will have what we call a solution set. Means it's going to be more than one option. There's going to be multiple things that we could possibly do. So when do inequalities show up in real life? Andre is going to the state fair with his friends. He can spend no more than $35 on rides, and each ride costs $4. So, can he ride 5 rides? Can he ride 6 or 8 rides? Can he ride 10 rides? So let's see. 5 rides at $4 each. So 5 rides times $4. How much is he spending? 20 bucks. Does that one work? Yeah, that one works. He can do that. He can do 5 rides. What about 8 rides? 8 rides times $4 each. 8 times 4? 32. Yeah, he's good. He can ride 8 rides. Okay, 10 rides. 10 rides times $4. 40. Can he spend $40? No, because he only had that $35. So, how do we figure it out? How do we figure out what are all the possibilities? Is it that he can only ride 8 rides? No, because he could also ride 5 rides. So there's multiple options. So our inequality is going to be $4 times however many rides, so I'm going to use R. And we're comparing that to 35, right? Because that's the total amount of money he has. So you have to ask yourself, is 35 the biggest amount of money he can spend, or is 35 the smallest amount of money he can spend? If that's all he has, if it's no more than, that means that's the biggest amount. So the big or the open part of the inequality goes toward the 35. Can he spend exactly 35? Yes, so we're going to have the equals to. That's our inequality. Okay? So we need to look at inequalities here. Let's talk about inequalities. So here's a number line to kind of help you see what we are doing. So let's start, and it says 3 is less than 5. So here's 3 on the number line, and here's 5. So 3 is less than or to the left of 5. Okay? So now let's add 2 to both sides. So I'm going to start with 3, and I'm going to add 2. That gives me 5. And I'm going to take the other side, 5. And I'm going to add 2. That gives me 7. So, is it still true? Is 5 less than 7? 5, 7. Is 5 to the left of 7? Yes. Okay, let's subtract 2 from both sides. So I'm going to start with 3 and 5. And I'm going to use a different color so you can kind of see what we're doing. Subtract 2 from each side. So this gives me 1, and this gives me 3. So is 1 less than 3? Here's 1, here's 3. Is 1 less than or to the left of 3? Yes. Okay. Start with the 3 and the 5 again. Alright, sorry about that. So let's get back to where we were. So we start with both 3 and 5, and this time we're going to multiply both sides by 2. So 3 times 2 gives me 6. 5 times 2 gives me 10. So we want to know, is 6 less than 10? Well, here's 6. Here's 10. 6 is to the left or is less than 10. Yes, that's still true. Okay, let's do it again. Start with 3 and 5. Multiply both sides by -2. So 3 times -2 gives me -6, and 5 times -2 gives me -10. So I want to know, is -6 less than -10? So here's -6, here's -10. Is -6 to the left of -10? No, it's to the right. So this one is not true. So we have an issue right here when we multiplied both sides by -2. It did not work. Okay, let's do it again. Start with 3, start with 5. I'm going to multiply both sides by +2. Or sorry, divide by +2. So 3 divided by 2. So remember, if you want to do a decimal, because I know you all like decimals better than fractions, 3 divided by 2 decimal point is 1.5. And 5 divided by 2 decimal point is 2.5. So is 1.5, so right here, to the left of 2.5, right here. So is this one to the left of this one? Is 1.5 less than 2.5? Yes, still works. Okay, one more to try. I'm going to start with 3 and 5. And this time I'm going to divide by -2. And again, because I know you all like calculators, 3 divided by -2 decimal point. So this one gives me -1.5. 5 divided by 2 decimal point. Whoops, forgot the negative. 5 divided by -2 decimal point. -2.5. So I want to know, is -1.5 less than -2.5? So let's look. -1.5 is right here. Is that to the left of -2.5 right here? So is this point to the left of this point? No. That one does not work either. So, in order to make both of these true, I actually have to flip the sign. -6 isn't less than -10, it is greater than -10. And -1.5 is not less than -2.5, it is actually greater than. So what's our conclusion? Why did it happen on those cases? So what's the same about these that the other ones don't have? Well, the key is right here. That -2. So if you multiply or divide a negative, you must flip the sign. Okay? So as we go through and solve on this next page, we've got to keep that rule in mind. If we multiply or divide by a negative, doesn't matter subtracting. Technically, that's a -2 right there. But that doesn't matter. Adding and subtracting don't count. Multiplying by a positive doesn't count. The only time it does is when you are multiplying or dividing by some negative number. Okay? So let's look at some of these examples on the next page. Alright, and we have a number line at the top. If you want to use that, it is up here for you to use as we go through. So, same idea as solving with equations, except now we just have the inequality sign. So we're still trying to solve for the variable. We're trying to get that x by itself. So that 4 is attached with multiplication. The way that you get rid of it is to divide. And whatever you do to one side, you got to do to the other. So those 4's cancel. I'm left with x is less than 28 divided by 4 gives me 7. So there's my solution. This is called my solution set. Meaning any number less than 7 works. Nothing greater than 7, and not the number 7, but anything less than 7. So the number 6 works. The number -15 works. And actually, because it's less than 7, the number 6.9999 works. Because it's not quite 7, it's almost 7, but it's not quite. So you can pick, for over here, any 3 things that are less than 7. You can pick 0. Any negative number will work. Any fraction or decimal that's less than 7 will work. Okay, let's look at the second one. -4 times x is less than 28. So I need to get rid of that negative. Divide by -4, divide by -4. And you should see a big warning sign going off in your head right now. Because what did I do right here? I divided by a negative. So what does that mean? This goes from a less than to a greater than. The rest of the problem stays the same. So the -4's cancel. I carry down my x. 28 divided by, oops, I forgot my negative right there. 28 divided by -4 is -7. So this is my solution set. X is greater than -7. So I can pick anything that is greater than -7. So x equals 0 is greater than -7. So here's -7, anything greater than, or this way. Notice it points that direction. So anything greater than -7. So you could pick -6. You could pick 4. You could pick decimals or fractions, whatever you want. Okay? So let me show you how the calculator will do what they look like if you try to graph these. Okay? So we're going to do new documents, don't save, add a graph. So, anytime you have something that doesn't start with y equals, so for instance, if I want to go back and graph number 1, 4x is less than 28. It doesn't start with y equals, or f of x equals. So I need to delete that equal sign, and then I need to pick option 6 right here, which is relation. Now I can type in anything that uses an x or a y. So this says 4x is less than, and your inequality symbols are right here above the equal sign. You can see them right there, so you have to hit Control equal sign, and I want to pick the less than 28. And this is what I see. So on my x-axis, I can actually count 1, 2, 3, 4, 5, 6, 7, and see that it hits at 7, and everything is shaded to the left, or all the numbers that are smaller than 7. X is less than 7. Okay? So, for instance, is 6 less than 7? Yeah. Is negative 15 less than 7? Yeah. And if you want to see exactly on your calculator what number that's at, if you're having a hard time reading your graph, you can do Menu, best button in the whole calculator, and then option 5, which is Trace, and then option 1, which is Graph Trace. And it'll tell you, yes, that X value is 7 on that line. Okay? Now, if I want to graph this one, okay, I'm going to hit Tab, and it says relation 2. I don't want relation 2. I want to go back up to relation 1, and I want to delete that out and put in my new one. So negative 4x is less than, so remember I find it there, 28. So this time it's on negative 7, and it's getting bigger. Everything bigger than negative 7 is shaded, so it goes that way. So you can use the calculator to check your answers as you go through. Okay, next one. Negative 66 is less than or equal to x over 4. So this says x over 4. That's divide. The way that I get rid of divide is to multiply. Multiply both sides by 4. Those will cancel. 4 times negative 66. So I'm going to add a calculator. So I did Control Doc because it says plus page right there. And so I want to add a calculator page. So I'm going to do 4 times negative 66. So I get negative 264 is less than or equal to x. So this is like using bad grammar. We always want the variable to come first. So I'm going to take this whole thing and I'm going to flip it. So I'm going to put the x on this side, the negative 264 on this side. So right here it opens up to the x, so I need to make sure when I rewrite it, it still opens up to the x. So this says x is greater than negative 264. So pick 3 things that are also greater than negative 264. And this time it does have equal to. Anytime it has equal to, you can use that exact number. So negative 264, negative 264. So think about it this way. Negatives. I need to be greater than a negative. So what is to the right or greater than negative 264? Well, negative 263. Or the easy way, what's greater than a negative? Well, 0, and any positive number is greater. So you can do that too. All right, let's do the next one, number 4. So I need to get rid of the minus 7 first. The way that I do that is to add 7 to both sides. (3x) is greater than 26 plus 7. You want to use your calculator. 26 plus 7, 33. Okay. Now, I need to get rid of this 3 out in front. It's being multiplied, so I need to divide by 3 on both sides. So then I get x is greater than 33 divided by 3 is 11. So let me show you what that would look like if I were to graph it. So I'm going to go back to my graph tab. I'm just going to click on it here. Then I'm going to hit tab and arrow up. So 3x minus 7 is greater than or equal to, that's that one, 26. It didn't do anything. Well, here's why. Do you see how our number was 11? Our graph only goes to 10 and negative 10. So we got to zoom out a little bit. So you can do menu. Actually, I want to try something here first. If I do menu, trace, graph trace, nope, doesn't do anything because it doesn't tell me where it's at. Oh, there it is. So if you do that, okay, that works. Menu, trace, graph trace. It will rescale it for you so that you can see what your answer is. Now you're going to have to be able to tell, is it greater than or less than? Because the hardest part is trying to figure out, do I need to flip the sign or not? So this time, stayed the same. I forgot my equals too. There we go. Okay, so this says greater than 11. X is greater than 11. 11 works because there is an equals to. Anything greater, 12, 13, look at what numbers are shaded. Not the ones smaller. The only ones you can pick are the ones that are shaded. Okay? So, let's do the next one. Subtract 13 from both sides. Negative 4x is less than 25 minus 13. That will give you 12. Divide by negative 4, divide by negative 4. Oh, what did we do right there? We divided by a negative. And what do you got to remember to do when you divide by a negative? Flip the sign. So it goes from a less than to a greater than. My negative 4's canceled, so x is greater than 12 divided by negative 4 is negative 3. So let's check that one. Let's make sure we did the math right. I'm going to delete this one out. 13 minus 4x is less than, there's my less than, 25. And then menu, trace, graph trace. It tells us we're negative 3, and the things that are bigger than negative 3 are shaded. So pick something that's over here. So I could pick 0, I could pick 1, I could pick 14, I could pick 217. Whatever you want. You just have to pick things that are greater than negative 3. So negative 2, 0, 15. Alright, next one. How do I get rid of plus 5? Minus 5 from both sides. So x over 20 is less than or equal 6 minus 5 gives me 1. Now this says divided by 20. The way you get rid of divide by 20 is to multiply by 20. Those cancel. X is less than or equal to 20. If I want to check that, I'm going to put in a fraction bar. So x over 20, make sure your arrow over, plus 5 is less than or equal to. So that's that one, 6. The whole thing's shaded. So let me trace it. And it tells me my answer is at 20. The things that are less than 20 are shaded. So I just need to pick up something that's less than or equal to 20. Well, 20 works because there's an equals to. And then things less than 19, 18. Okay, so we can keep going. We can keep solving all of these problems here. They do get a little bit harder. So I want you to pause the video and I want you to try these next few on your own. And then I want you to turn the video back on and check your answers. Alright, let's check problem 7. So you need to distribute first. Distribute that negative 4. Negative 4x minus 20 is less than or equal to 4. Get rid of the 20 by adding 20 to both sides. Then divide by negative 4. Uh-oh. Look at there. Divide by negative 4. Anytime you multiply or divide by a negative, what do you got to do? Flip the sign. So x is greater than or equal to negative 6. So this is a really good thing that if you are forgetting this rule, make sure you are checking them in your calculator. So let's check this one. Negative 4, parentheses, x plus 5, close your parentheses, is less than or equal to 4. Again, the whole thing looks shaded. Menu, trace, graph trace. I got to hit up or down to get to negative 6. Now, what if I had forgotten? This would have said less than. Or the things that are to the left or less than negative 6 shaded? No, it's the things that are to the right. So it is a greater than or equal to negative 6. Okay, so what's greater than negative 6? Well, you can see here. I'm going to include negative 6 because that isn't equal to, and then negative 5 and negative 4. Okay, next one. We got to get rid of the 17. It is a positive 17, so we need to subtract 17 from both sides. 13 minus 17 gives you negative 4 is greater than negative x. Okay, that's like a negative 1 being multiplied out in front, so I need to divide by negative 1, divide by negative 1. Oh, look what we got there. We are dividing by a negative. So what I got to remember to do? Flip that inequality sign. Negative 4 divided by negative 1, so negative divided by negative is positive. 4 over 1 is 4, and those cancel to give me x. Now again, this is bad grammar, so I'm going to take the whole thing and I'm going to flip it. I'm going to put the x on this side, the 4 on this side. See how it opens up to the x here? It is still going to open up to the x in my final answer. So x is greater than 4. So pick 3 things that are greater than 4. How about 5, 6, and 7? Okay, these next two, there's some work, some combining, that kind of thing. Got to make sure we get all of that work done there. Okay. All right, so I'm going to distribute here. So 33 minus 6x is greater than 24 plus 3x. Okay, now I've got variables on both sides. Here's the thing with inequalities. I always like to move them over to the left, because if you end up with them on the right, you got to flip it over to the left anyway. So I'm going to subtract 3x from both sides. 33 minus, so negative 6 and negative 3 gives me negative 9x is greater than 24. Okay, I'm going to move the 33 to the other side. It is a positive 33, so I need to subtract 33 from both sides. Negative 9x is greater than 24 minus 33. So I'm going to use my calculator for that. 24 minus 33. That's going to give me negative 9. Okay. Divide by negative 9, divide by negative 9. X is, did you catch it? Right here. I divided by a negative. So my sign goes from a greater than to a less than. And negative 9 divided by negative 9. Negative divided by negative is positive. 9 over 9 is 1. So x is less than 1. So what's less than 1? 0, negative 1, negative 2. All right, let's do this last problem here. So I've got some cleanup work to do first. I need to distribute this 2. So 2 plus 4x plus 3x is less than or equal to negative 12 plus 9x. And then I need to combine my like terms. So 2 plus 7x is less than or equal to negative 12 plus 9x. Then I need to get all of my x's on the same side because I have some on the left and some on the right. So you have two options here. You can either subtract the 7, so this is a plus 7x. So you could subtract 7x and move it over here. But then at the end, if we end up with it over there, then we've got to switch it back. So I think it's easier to just always move it to the left when you have inequalities. So minus 9x minus 9x. So 2, then 7 minus 9 minus 2x is less than or equal to negative 12. This 2 right here is positive, so the way that I get rid of it is to subtract 2 from both sides. Negative 2x is less than or equal to negative 12 minus 2. negative 14. That negative 2 is being multiplied, so the way that I get rid of it is to divide by negative 2. Did you catch it? Right there, I divided by a negative. So I have to change my less than or equal to a greater than or equal to. And I'm left with x is greater than or equal to, negative divided by negative is positive, 14 over 2 is 7. So things greater than or equal to 7, well, 7, because that's the equal to, and then greater than 8, 9. And if you want to check that one, okay, so let's check this in the calculator here. So I'm going to type in this whole original problem. Oops, forgot to delete the equal sign and pick a relation. There we go. Okay, so you can count 1, 2, 3, 4, 5, 6, 7. X is greater than or to the right from 7.